In the first two videos in this series, I described how DCC worked very briefly, and then I explained in much more detail in video 2 how the packet structure of DCC worked and how the digital signals worked. In video 3, I want to explain how the motor shield, the R3 motor shield for the Arduino Uno works as it's used in DCC. So to implement DCC with Arduino Uno, you need the Uno, you need the R3 motor shield. R3 is just the latest version of the motor shield, and they are connected together. When you insert the motor shield on top of the Uno, the pins from the bottom here fit into the pins here and connect, and whatever voltage comes up in these connectors at the bottom or the side of the Uno appear in the top of the motor shield. To assist in the description of the motor shield, I've drawn this diagram of the connectors. It's not to scale or to shape, so this diagram only contains the connectors. It doesn't show the integrated circuits on here for clarity reasons. In the first half of this video, I'm going to explain the outer connectors. In the second half of this video, I'll explain the inner connectors here. But for the time being, for clarity, I'm going to remove these inner connectors from this diagram and put them in later when I start explaining what they use. There are two output channels in the motor shield, channel A and channel B, and they're both identical, although they can contain different signals. Channel A can be used to control one track, and channel B can be used to control the engines on a second track. And channel A is controlled by signals from the Uno in pin 12, pin 9 and pin 3, and channel B, completely separately, is controlled from signals on pins D13, D11 and D8. Before we start though, I need to point out that a model train won't run on a typical 5 volts that an Uno runs on, so you're going to need to connect a higher voltage to the motor shield to power the trains, and I've used 12 volts, which is an output from an old laptop connector. You can use higher volts, 14, 16 volts or 10 volts. Putting 12 volts in here means that 10 volts appears out of here, or 10 volts appears out of the B channel, because 2 volts is lost in the integrated circuits here. The plus 12 volts go to the second pin, and this plus 12 volts appears also on the V in pin 0, or the power connector, which can be used for other purposes. The negative voltage for the power supply goes to the bottom pin, the ground, and ground is also connected to pins 1 and 2 here. It's also connected to pin D14 up here. So all these grounds are connected together. Going through the 3 connect pins now that control channel A. Pulse width modulation A must be set to +1 at all times, and setting PWMA for channel 1 pulse width modulation A to +1 makes sure that 12 volts or 10 volts is output from channel A. The direction A toggles between 0 and 1. If it goes to 1, you get plus 12 volts out of here, and if it goes to 0, digital 0, minus 12 volts come out of here. So toggling this in the normal output of Uno, which is between 0 and +1 or 0 and 5 volts, toggles the output voltage here between plus 10 volts and minus 10 volts. The connector break for channel A is not really used with DCC. It's used with robots, and the break A must be set to low at all times, which it normally is if you don't control it. If you set break A to 1, it immediately disconnects the power to channel A. So break A, as its name implies, is an emergency brake. So we always set this to 0 in the sketch. You can leave it not connected, and it defaults to 0 anyway. Channel B has similar connections up here and operates in the same way. They're not connected in the computer, so what happens on A is independent on B, but you can run two different sketches on the Uno controlling channel A and channel B separately. I mentioned PWMA. It's set permanently to high, so if in setting it permanently to high, you're either going to get plus 10 volts out of here or minus 10 volts out of here, depending on the direction of dir A. If dir A is 0, you're going to get minus 10 volts out of here. If dir A is plus, you can get plus 10 volts out of here. Okay, so by digitally altering the signal between 0 and 1, or 0 volts and 5 volts, you get between minus 10 and plus 10 volts digital signal out of here, which is a signal we need for DCC, the shape the signal we need for DCC. So these are the only connections we need to run DCC. We need PWMA and we need dir A. That's all we need to alter in our sketch to run DCC on our tracks. So in this sense, that's all we need to know about the motor shield. The rest of the connectors doesn't matter. But just for a general interest or general education in the use of the motor shield, I'll explain how all the other connectors work. Dir A, break A, and PWMA controls channel A, and as I said, dir B, pin 13, pin D11, and pin D8 independently controls channel B. So you can run two sets of tracks, although typically this second track is the control track. These two left pins here, D16 and D17, are used for a communications protocol if you want to connect external equipment to the motor shield. In particular, it implements the SCL SDA communications protocol. SCL stands for serial clock and SDA stands for serial data, where the data is actually transmitted. The two rightmost connectors here, TX and RX, D0 and D1, are also used for communications with external equipment, and they're used for UART communications. And there's a lot of information on the web on how to implement SCL, SDA, and TX, RX. Now, these bottom pins down here, A0 to A5, they can be used for digital signal inputs, 0 or plus 1, or 0 volts and plus 5 volts. In the same way, digital inputs can be input or output here. It can be input or output here. But these A0 to A5 connectors can also be used as analog to digital converters for inputting analog signals and converting them to digital signals for analysis by an Uno sketch. Okay. In general, it'll just revert as a reference to the 5 volts provided by the power supply for the Uno. But if you want to have an accurate analog to digital conversion, then you can put an accurate input voltage into pin D15, and this acts as a reference voltage for the A to D converter, which isn't necessary, but it does make the A to D conversion process much more accurate. The other two connectors, A0 and A1, in general, you get analog or DC, analog voltage out of channels A and B. Now, if I was to put a short circuit across the rails in A, say the train derailed and it shorted the circuit, I could destroy all the ICs in here, or some of them, by having too big a current through it. And what pin A here does, it can act as a power sensor. It can act as a current sensor for the circuit in A. So I can monitor on the Uno what power is coming through channel A here, pin A, and if it gets too high, I can shut off the power very quickly. So pin A acts as a current sensor for channel A, and pin A1 can act as a current sensor for channel B to sense the current on the track, and if it gets too high, to do an emergency shutdown. Output power. If I need to power external equipment with the Arduino, typically from my laptop I supply 5 volts to the Uno, or through an external power supply, through like a battery I can supply 5 volts. Whatever voltage pin 3 provides 5 volts external power for other connectors. Pin 4 here provides 3.3 volts to power external connections. Pin 6, whatever voltage I provide from my laptop to power the Uno turns up on pin 6 as well. You can use it to power external equipment, or it can be used as a reference for other equipment. Pin 7 here is not currently used by the Uno or the Shield. It's reserved for future use. So sometime in the future, pin 7 might be used, but it's not used at present. Apart from that, these are the connectors that are used. Pins 2, 4, 5, 6, 7 and 10 up here are not used by the motor shield and can be used for other applications by the Uno to connect other equipment to it. Okay, so they aren't used, but we can use them in the sketch if we want to. Emergency reset, or if the Uno and the motor shield get stuck in a loop and you can't get out of it, this reset button here, if you press the reset button here, the voltage on pin 5 changes from logical 1 or 5 volts down to 0, and this resets the software both in the motor shield and in the Uno. So this is a reset. You can artificially reset, not by pressing the reset button, but by grounding it, and that does the same, resets the software. Now move on to the connectors in the middle here, these ones here. They're used to connect external equipment to the motor shield to control them or to bring input data in. There are 2 4-pin connectors at the front, and there are 4 3-pin connectors at the back here. These bottom 6 connectors plus these 2 connectors here connected to ground. So these 6 connectors, D14, the ground here, and pins 1 and 2 here are all connected to a common ground. 5 volts out of pin 3 in power. these connectors here, these pins here, these top 4 here, and these 2 second from the bottom here are also connected to the same 5 volts as pin 3 is to power any external equipment. In the 2 connectors on the left hand side, the top 2 connectors are connected to the data communication channels SCL and SDA, and the top 2 pins on the second connector are also connected to SCL and SDA pins D16 and D17 to communicate with external equipment. Pins 5 and 6 here are connected to pins 5 and 6 here. These 2 middle pins are connected to 5 and 6 here for digital input-output to the Uno. And these 2 pins here in the leftmost and the rightmost 2 connectors are connected to analog pins 8, 2 and 3. You can use them for digital input-output, but they also have the advantage you can use them for analog signals as well. The motor shield on the Arduino, if it runs on greater than, say, 14 volts, you could bust the circuit. If you've got your own, certainly will bust the circuit. So if in some robot you want to put, say, 20 volts in here, you need to modify the shield so that 20 volts in here will appear in channel A and channel B, but won't be passed through the ICs. If you put a very high voltage into V-in, this connection at the bottom here, you need to cut with a small craft knife. Okay, you need to cut across there, and this disconnects the high voltage, say 20 volts, in from the rest of the integrated circuits, but still has it going out on channels A and B. I mentioned brake A and brake B aren't used in DCC, but they are connected to the Uno. So as a default situation, you can't use the pins for brake A and B for brake A and brake B for other applications. If you short of output pins here, you can disconnect these, cut them across here. This will free up the 2 brake A and brake B pins for other digital applications to control other equipment. And what you do is you have a very fine knife, you cut across here. You be extra careful in cutting through it, because if you make too big a cut through the outer board, it'll cut circuitry underneath and it'll break the board, which I've actually done here. It's a pain in the neck. And because I assume that putting higher voltage into the motor shield is quite a common application, I don't know whether they just don't put jumpers across here to make it as easy, instead of making a lot of people break their boards. So the Arduino motor shield is connected differently when used for DCC than with PMW motors. I've explained what it's used for with DCC. There are further differences, not in the output of the motor shield when you use it for a robotic application, but the way the voltage is transferred to the output channels A and B is different with DCC than it is with pulse width modulation. And in video 5 of the series, in 2 videos time, I'll explain how pulse width modulation works, as distinct from how it works for DCC. But what I'll explain to you now is all you need to know about the output pins for an R3 motor shield and how it's used for DCC. Okay. Thank you very much, and I'll go on to part 4 in the next video and explain how the DCC Arduino sketch works, or at least my DCC sketch, which really is only there to show you how to put voltage onto a DCC voltage onto a track and to get the train moving forward or backward, and some other applications. It's not meant to be something like DCC++, which is a full suite of applications and very sophisticated. My DCC was just there to show me how DCC worked.